All right. Turbidite deposits are just, or turbidity currents are just one example of hyperpycnal flows. As I said before, hyperpycnal means flows that are denser than the fluid around them, therefore they flow downhill. Um, and the reason they're denser than the water around them is because they have so much sediment inside of them, right? So just like uh, coffee is denser than water because you added solid coffee particles, or hot chocolate is denser than water because you added that like chocolate powder. The turbidity currents are denser than water because they have that sediment suspended inside of them, and the sediment is denser than the water. So because of that, because they have a relatively high density, they can move very, very fast downhill. They don't have to move fast. Some of them move slow, but they can move very quickly. And when they deposit, as we just said, they deposit from coarse to fine. Coarse at the bottom because that's where the high energy head is going to be. And then over time, fine at the top because that's where the low energy tail is going to be. We call this graded bedding. In this specific example, it fines upward, meaning the energy is decreasing as you go upward in the sequence. In these graded deposits, again, large sediment deposits first, and then it's covered by progressively finer material. So each coarse to fine sequence records a different flow event, which means if you look at a deposit like this, you can figure out how many turbidity currents have flowed through here through time, right? Because you want to look for a very coarse layer that fines upward, and that's one event. And then when you see another coarse layer that fines upward, that's another event, and so on and so on and so on. So how many flow events do you see? Give yourself some time here. Pause me if you need to. I'm just going to tell you the answer because I want to make sure you see it. I see three, right? We get that coarse material at the bottom that fines upward once, and then another coarse layer that fines upward, a final coarse layer that fines upward. You could argue that there's another coarse layer on top of that, so we can see this beginning of a fourth turbidite layer. But at least for full, solid, complete layers, I see three of them. I want to know, why do we care about hyperpycnal currents on the seafloor if they are so far away from us? I want you to make a list for yourself, all of the different reasons you can think of. Um, if these underwater landsides are underwater, why do we care?